Good morning, dear students. Today we'll start with chapter number 1, rational numbers. Now, you already have some idea about rational numbers, you've done it in class 7th. But before I start, I would like to review the whole thing so that we don't have any problem to start with. Now, let's see. First of all, you have studied about natural numbers, that is n. Now, what are natural numbers? Most of the students give me the definition that all numbers from 1 to infinity are natural numbers. Now, do you think that definition is correct? I don't think so that definition is correct. 1.5 also lies between 1 and infinity. But do you think it is a natural number? No. So what is exactly the definition of natural numbers? All counting numbers are called natural numbers. How do you count? 1, 2, 3, 4, 5 and so on. This is how you count. So these counting numbers are actually called natural numbers. So let me write it. 1, 2, 3, 4, 5, 6. These are all natural numbers. Then came the set of whole numbers. Now what are whole numbers? If you include 0 in the set of natural numbers, it becomes the set of whole numbers. So 0 was also included and so on. So this becomes whole numbers. Then naturally, as maths progressed further, as life progressed further, so there was a need of negative numbers. So how did this negative numbers start? 0, 1, 2, 3, these are all positives. Now negative of 1 is -1, negative of 2 is -2, negative of 3 is -3 and so on. You can go on because this side you can go on, then this side also you can. You have 4, 5, 6, so you have -4, -5, -6 and so on. So this became the set of integers. Now we should be very sure about integers because that is how we are going to define what are rational numbers. See, what are integers? Integers are 0, natural numbers and negatives of natural numbers. 0, natural, these are positive integers, or so you can say them that these are natural numbers and these are negatives of natural numbers. Now this entire set is called the set of integers. After dealing with set of integers, we came to rational numbers. We use the symbol Q for rational numbers. Now we don't use R because of course rational number starts with R, but we don't use R. R is used for real numbers, not for rational numbers. We use the symbol Q for it. Now what are these rational numbers? As you can recall what you have learnt in class 7, rational numbers are those numbers which can be written in the form P upon Q. P and Q are integers, and very importantly, Q cannot be 0. Also, they are in P and Q are in lowest terms. Now I'll define that later. What do I mean by lowest terms? First of all, lowest terms of course means that you can't cancel any further. For example, if you write 2 upon 3, you can't cancel any further. But if you write 4 upon 6, you can say okay, 4 2 times, 3 times. So this 4 by 6 is not in lowest terms, but 2 by 3 is in lowest terms. Now coming to, let us take some cases and find out whether these numbers are rational numbers or are they not rational numbers. For example, suppose I write the number 5 by 6. How will I check? Okay, 5 by 6, 5 is an integer, 6 is an integer. What did I say here? P and Q both must be integers and the denominator or Q must not be equal to 0. So you can see 5 and 6 both are integers, fine. And then you can again see that the denominator is not equal to 0. So even that is okay. So yes, is this a rational number? Yes. Suppose I write -2 by 3. Now -2 is an integer, you can see it here. It is a negative of a natural number, so obviously it is an integer. 3 is also an integer, you can see it in this set. So both of them are integers and the denominator is not equal to 0. So yes, very much. Let us take this case 0 by say -2. Now this creates some confusion because we had talked about something like not equal to 0 or something. Let's see. Both should be integers. Yes, rule number 1 is followed. Both are integers. 0 is also an integer. -2 is also an integer. Denominator should not be 0. We never said numerator can't be 0. Denominator cannot be 0. So yes, denominator is not 0. Denominator is minus 2. So both the conditions are satisfied. Of course, all of them are in lowest terms, which I am taking right now. So yes, is this a rational number? Yes, this is very much a rational number. Now suppose I take minus 2 by 0. Now minus 2 is an integer? Yes. 0 is an integer? Yes. But I had said what? The denominator cannot be equal to 0. So there is a problem here. So obviously, is this a rational number? No, this is not a rational number. So how are we going to identify number is rational or number is not rational? This is the way we will identify. Good. Yes, let us continue with our lesson. In lesson number 2, I'll be talking about properties of rational numbers. Now, what are the properties of rational numbers? As you had read, first of all, I'll go through some properties of natural numbers, integers, etc. Then I'll carry that forward to rational numbers. See, let us talk about the operation of addition. Now, when we talk about addition, you see, you all have read that 2 plus 3 is same as 3 plus 2. This is called the commutative law. What do you mean by commutative? Commute means to go from one place to another. Like you come from school, then you go back from school to home. So this is commuting from school to home and home to school. So same way, these numbers have commuted their positions, exchanged their positions. So that is why, but of course 2 plus 3 is same as 3 plus 2. So what we say? We say that this is commutative law. Commutative law or commutative property, whatever you like to call it, you can call it that way. Then we also know that 2 plus 3 plus 5, I can do like this, or I can do like this. 2 plus 3 plus 5, 3 plus 5 is 8, 2 plus 8 is 10. Or I can do 2 plus 3, 5 first, and then 5 plus 5 is 10, one and the same thing. So this is called associative law, or maybe associative property, one and the same thing. Association means coming together. So what has happened here? Here second and third term have come together. Here first and second term have come together. So that is why we call it as associative law. Then we used to say identity. Okay, 2 plus 0 is same as 2. Even if 0 plus 2 is same as 2. So what is 0? 0 is the identity. Identity is like looking in a mirror. If you look in a mirror, you get your own image. You and your image must be same, will be same in any case. So same way here, 2 plus 0 gives the same number, 2. You can reverse it, you can tell it 0 plus 2. That is also 2. So this is called additive identity. Then, now is it possible that 2 plus something gives you 0? Maybe in natural numbers you can't do it, in whole numbers you can't do it, but in integers of course you can do it. 2 plus minus 2 is 0. 3 plus minus 3 is 0. Minus 7 plus 7 is 0. So what are the relationship between 2 and minus 2? Negative of 2 is minus 2. Negative of 3 is minus 3. Negative of 7 is minus 7. So if a number is added to its negative, we always get 0. Or a negative is added to its positive, then we always get 0. What do you call them? 2 is, or minus 2 is additive inverse of 2. Same way here, minus 3 is additive inverse of 3. 7 is additive inverse of minus 7, and so on. So every integer has got what? Every integer has got additive inverse. Now these are the 4 properties of addition I've talked about: commutative, associative, identity, and inverse. Now let us see that are these properties also going to be there when we are going to talk about rational numbers. Just give me a moment. Remember, I'm talking about addition. Okay. So suppose I have 2 by 3 plus say 3 by 2. Will it be equal to 3 by 2 plus 2 by 3? let's say this is a question. I'm not saying this is correct. 2 plus 3 is 2, LCM 2 and 3 is 6. 2 into 2, 4 plus 9. Here also same way. 9 plus 4, what do we get here? 13 by 6. Here also I get 13 by 6. So what do I get? I get, yes, it is correct that they are equal to each other. So that means A plus B is equal to B plus A. What was this A plus B equal to B plus A? This was commutative law. So you can see this commutative law is holding. Now we'll talk about whether associative law is holding or not holding. Let's see. See, A plus B plus C. Okay. And on the other side we had what? A plus B plus C. I just mentioned that association means, associative law comes from the word association. Association means what? Coming together. Are they coming together? Coming together, how can in maths we can come together? In maths we can come together by putting a bracket. So that is what I have done here. Second term and third term in one bracket, or first term and second term in one bracket, one and the same thing. Let's see. Suppose I have half plus say 2 by 3 plus say 3 by 4. So I can put like this. Here I can say half plus 2 by 3 plus 3 by 4. I can also put it here. So half plus, this is 12, 8, 3 into 3, 9, half plus 17 by 12, LCM again is 12 only. So here 6 plus 17, what does this become? This becomes 23 by 12. Here again LCM is 6, 3 plus 4 plus 3 by 4. 7 by 6 plus 3 by 4. Take the LCM, 24. Okay. 7 into 4, 28. 6 into 3, 18. 28 plus 18. 28 plus 20 is 48 minus 2, 46 by 24. You cancel it. It becomes what? It becomes 23 by 12. So here also the total came 23 by 12. Here also the total came 23 by 12. So are they equal? Yes, they are equal. So commutative law also holds. A plus B plus C is equal to A plus B plus C. So associative law also holds here. Now our next thing will be about identity. That is, their identity is also possible. That means if I add 0 to a number, will I get back the same number or I will not get back the same number? A plus 0 is equal to what? Suppose I have 2 by 3 plus 0 will be, what will it be? 2 by 3 only. So that means A plus 0 is A. Now let me try 0 plus A. Okay, even if you take LCM, what does it become? 0 plus 2. So again it becomes what? 2 by 3. So this is also 0 plus A. So identity also holds. Identity also holds. And what is 0? 0 is the additive identity. Let's see, is there an inverse also? That means if I think of any rational number, suppose I think of say 4 by 6. Oh, sorry, let me take something else. Say 4 by 7. Now, is it possible that I add something to 4 by 7 and I get the additive identity 0? Yes, it is possible. What is that number? That number is minus 4 by 7. Now think about 4 by 7 and minus 4 by 7. Minus 4 by 7 is the negative of 4 by 7. Or minus 4 by 7 is the negative of 4 by 7. They are what? Inverses of each other. Now, so does 4 by 7 has an additive inverse? Yes, 4 by 7 has an additive inverse. So additive inverse of A by B is minus A by B. Now there are certain things we must know about this. What is additive inverse of 1? additive inverse of 1 will be what? Minus 1. See, 1 means what? 1 means 1 by 1. So if you put minus here, it becomes minus 1 by 1, and that is minus 1. Then additive inverse of minus 1. Well, we have to only change the sign. Plus 1. Additive inverse of 0 is going to be 0. You say plus 0 or minus 0. It doesn't matter, because 0, if you put any sign in front of 0, that remains 0 only. So additive inverse of 0 is 0. This is the only number which is additive inverse of itself. Remember this point. This can be asked in MCQs or something. This is the only number which is additive inverse of itself, that is 0. So here it is that 0. Now, so if we finish with the properties of addition once again. Yes, so now let us, we have just done properties of addition. Now let us continue with properties of multiplication, division, etc. Sorry, first of all, I'll take up subtraction. The next operation is subtraction. Now when we talk about subtraction, there are not many properties, only 1 or 2 properties. I can say, okay, now first of all, is it true that a minus b will be equal to b minus a? 2 minus 1 is 1, but 1 minus 2 is minus 1, and 1 is not equal to minus 1. So this property is not correct. So we can't say that a minus b will be equal to b minus a. So we can say commutative law does not hold. Similarly, a minus b minus c, a minus b, what does this become? This becomes a minus b plus c. And this becomes what? This becomes a minus b minus c. Now signs are different. You have subtract a minus b, then add c. From a you subtract b, then subtract c. So obviously this can't be true. So associative property, not true. Commutative property, not true. Associative property, also not true. Now, is there an identity? Yes, a minus 0 will be equal to 0, will be equal to a. But the reverse part is not true. That is, 0 minus a should also be equal to a. Now, this cannot happen, otherwise minus a will become equal to a. But this can't be said. Minus 2 is never equal to 2. Minus half will never be equal to half. So obviously, this property, you must understand that both sides it must be correct. Like he had a plus 0, we also had 0 plus a. So say we had a minus 0, but we don't have 0 minus a. So again, identity, not true. Now if there is no identity, there can't be inverse. Because what was inverse? Inverse was we add a number, like for example, 2 by 3 plus its additive inverse should give you 0. What was 0? 0 was additive identity. Now here we don't have identity of multiplication. So obviously we can't talk about this property. So inverse is also not there. Now only one property is left. What is that property? That property is closure property. Is closure property satisfied? Let's see. Suppose I do 2 by 3 minus half. Okay. LCM is 6. 4 minus 3, 1 by 6. We again get what? We again get a rational number. So rational number minus rational number is again a rational number. I can write like this. Rational number minus rational number is again a rational number. So closure property, yes, is true. So when we come to this operation of subtraction, what happens? Only closure property is true. Otherwise, remaining all properties are not going to hold here. Now our next operation is the operation of division. Multiplication. Now multiplication is also going to be very interesting. Multiplication or multiply as you call. See, a into b, b into a. 2 by 5 into 3 by 6 or 7, and here 3 by 7 into 2 by 5. 2 into 3, 6, 35, 6, 35. Both of them are correct, both of them are same. So obviously this is true. So commutative law, yes, holds. Again same way, a into b into c,
A into B into C. So here suppose I have 1 by 2, 2 by 3 and say 3 by 4. Here I have 1 by 2, 2 by 3, oh sorry this is wrong, should be like this, into 3 by 4. Now what is there in multiplication? First we have to solve it. 3 cancels 3, 2 by 4 becomes half, and here 2 cancels 2, it becomes 1 by 3 into 3 by 4. 3 and 3 get cancelled, this becomes 1 by 4, this also becomes 1 by 4. Are they equal? Yes, they are very much equal. So you can see associative law also holds. I'll have to rub this. Now, talking about identity. Now we all know that 2 by 3 into 1 will be equal to 2 by 3. And is the reverse true? 1 into 2 by 3. 1 into 2 by 3 is also 2 by 3. So obviously A into 1 is equal to A, it is equal to 1 into A. So commutative law is true, associative law is true, and multiplicative identity also exists. Is there a multiplicative inverse, and is it going to be true for all the values? So can I multiply 2 by 3 by something which will give me 1? Yes, I can. That is 3 by 2. Is the reverse true? The reverse is also true. You can easily verify it. But what about 0? Can I multiply 0 with something which will give me 1? Can you think of any such number? No, no such number exists. So multiplicative inverse exists for all the things except 0. So what we say, we don't talk about multiplicative inverse here. I'm sorry, we don't say multiplicative inverse exists. Inverse, sorry, this doesn't hold. Why? Because for 0 it doesn't hold. It holds for everything, but not for 0. So will it hold for each and every number? No, it will not hold for 0. You can remember this point, that multiplicative 0, inverse of 0 is not possible. By multiplicative inverse, we also mean what is called the reciprocal. That 0 is reciprocal. How can you have reciprocal of 0? Reciprocal of 0 will become what? 1 by 0. And do you think 1 by 0 exists? No, 1 by 0 does not exist. Now in later classes you will learn why 1 by 0 does not exist. At the moment, let us take it for granted that 1 by 0 does not exist. So multiplicative inverse also does not exist. Closure property. Is it closed? Let's see. 2 by 3 into 3 by 5. So 3 cancels 3, 2 by 5. So what do we have? We have rational number into rational number is again into a rational number. So this is correct. Closure property holds. So we have 5 properties, 1, 2, 3, 4. In fact, sorry, we have only 4 properties. This does not exist. So we have what? We can say, okay, it is closed, it is commutative, it is associative, there is a multiplicative identity, but there is no multiplicative inverse. I'm going to talk about division. Now all of you know what is division. I don't need to elaborate much on it. So suppose I have A divided by B. That is say 2 by 3 divided by say half. Now what is division? How do we do it? We say, okay, 2 by 3. Instead of division, we put multiply sign, and instead of 1 by 2, we will put 2 by 1. So what is that? That is 4 by 3. Now let me do B divided by 2 by, half divided by 2 by 3. Half, again, instead of division, we put multiplication. Instead of 2 by 3, we put 3 by 2. So what do we get? We get 3 by 4. Are the numbers equal? No, 4 by 3 can't be equal to 3 by 4. 4 by 3 is an improper fraction. 3 by 4 is a proper fraction. They can't be. Improper fraction cannot be equal to a proper fraction. So they are not equal to each other. So what can we say? We can say A divided by B is not equal to B divided by. Remember? We did A minus B not equal to B minus A. Same way A divided by B is also not equal to B divided by A. So is it commutative? No. Okay. A divided by B divided by C. Let me put these two together. So let me take say half divided by 1 by 3 divided by 1 by 4. Okay. Half divided by 1 by 3 into 4 by 1. Half divided by 4 by 3. Half into 3 by 4. So it becomes what? 3 by 8. So let me try divided by C. A is half divided by B. B is how much? B is 1 by 3 divided by C. C is 1 by 4. 1 by 2, 3 by 1 divided by 1 by 4. 3 by 2 divided by 1 by 4. 3 by 2 into 4 by 1, that is 6. 3 into 4 is 12. 12 divided by 2 is 6. Now are these two equal? No. A divided by B divided by C is not equal to A divided by B divided by C. So what can we say about it? That of course, like we earlier had said, commutative property not possible. Then is associative property possible? Associative property is also not possible. I'll have to rub this. Okay. Now, commutative and associative both properties are not possible, as we have seen. Let us talk about identity. Is it possible that, okay, let's see, say A divided by 1 is equal to A. Is it correct? Yes, of course. But when we reverse this, 1 divided by A, is this equal to A? No, because 1 divided by A will become what? 1 by A. So obviously, an identity is not possible. Now, as we had read earlier, if identity is not possible, inverse will also not be possible. So naturally, inverse is also not possible. Now, is it always closed? That means A divided by B will always, rational number divided by rational number will always be a rational number. Maybe. Suppose I have 2 by 3 divided by say 1 by 2. So what will become? 2 by 3 into 2 by 1, 4 by 3. So here we are getting rational divided by rational is equal to rational. But is this always going to be true? Now we accept something as a property when it is always true. We don't accept it as a property when it is not always true. So what happens if this rational number is equal to 0? So a rational number divided by 0 is a rational number. Is this possible? Well, division by 0 is not defined. You can't divide any number by 0. So obviously this is not going to be there. So again we can say closure property is also not actually satisfied. Now what do we accept as properties? So we write 2 or 3 things which are not always correct. I say A divided by 1 is equal to A, brackets is not equal to, A divided by 1 equal to A, correct, but I don't write the reverse part of it. I never write 1 divided by A. I also say A divided by A is equal to 1. In the bracket, I take A not equal to 0. So I'm taking away that possibility that we are dividing by 0. Now these two things are taken as properties of division as far as rational numbers are concerned. However, they are not exactly properties. A divided by 1 is equal to A, okay, fine. But the reverse part of it, that is this, is not going to be possible. So 1 is not taken as an identity, only taken as something else. So we will take these two as properties of division. So with that we come to the end of properties. One more property is there. That property is about, that's not exactly one of the operations, but a combination of operations. This is what is called the distributive law. A into B plus C is A into B plus A into C. You see, A into B plus, this plus is here, A into B plus A into C. This is called distributive law. Why called distributive law? Because multiplication has been distributed over addition. There is one multiplication sign, now there are two multiplication signs. So what is there? Multiplication is distributed over addition. So that is why it is called what? It is called the distributive law. Distributive law holds. So you have 2 by 3 into say half plus 1 by 4. So you can say okay, 2 by 3 into half plus 2 by 3 into 1 by 4. So this is what is called the distributive law. Distributive law holds. So for division, we have now completed each and everything as far as properties are concerned. So kindly go through them, kindly go through the video once again. You will be able to do all of them. Yes, please. Now we come to another topic, that how to show rational numbers on a number line. It can be very intriguing and confusing at times. So let us try and see how are we going to show the rational numbers. Let us take some rational numbers. This is more done by examples than by any theory. Suppose I want to show say 2 by 3. Now what type of 2 by 3 will lie between 0 and 1? It's a proper fraction otherwise. So what is it going to be? It is going to lie between 0 and 1. So I can say, okay, if I have something from 0 to 1, a number line from 0 to 1, I will be able to easily get and how to write it, how to show it. So here is my number line. With number line, the first thing you want is 0. The next thing you want is 1. So how to do it in a manner that you are able to do it quickly without any real trouble as such? See, look at the denominator. The denominator is 3. So say, okay, 1, 2, 3, and this third division, you take it as 1. So what have you done? You have divided one unit into 3 parts, or you have taken 3 parts so that you get 1 unit. You have gone the other way around. In fact, what is 2 by 3? Okay, 1, 2. This is 2 by 3. Now suppose you want to do say 5 by say 6. Again, this is lying between 0 and 1. In first cases, I'll take all between 0 and 1. So let me take like this. Now see the denominator. Denominator is 6. So I start with 0. 1, 2, 3, 4, 5, 6. So here is 1. Now out of these 6 parts, how many parts you are supposed to take? You are supposed to take 5 parts. 1, 2, 3, 4, 5. So this is your number 5 by 6. I think this is relatively much easier than doing it the other way around. So instead of dividing one unit into 3 parts or 6 parts or 5 parts, what I have done is I have taken 6 parts and converted them into 1 unit. Now suppose I have say 5 by 7. So again same way, 0, 7 your parts, denominator 7, 1, 2, 3, 4, 5, 6, 7. So 5 out of 7 parts, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So here it is 5 by, this is what? This is my 5 by 7. So with these 3 cases you understand that how do you do it. Now next is, let me take some negative ones, say 2 by 3. Now 2 by 3 will lie between what? Will lie between 0 and or minus 1 and 0. It is going to be on the negative side, but 2 by 3 is still proper fraction, so naturally it has to be less than 1. So how do I do it? Okay, I say 0, 1, 2, 3, this is minus 1. How many parts I have to take? I have to take 2 parts out of the 3 parts. So here it is minus 2 by 3. Now suppose I want to do minus 5 by say 8. Again you can see 5 by 8 is a proper fraction, so it will lie between what? It will lie between minus 1 and 0. So let us do it. 0, 1, 2, 3, 4, 5, 6, 7, 8. Here it is. Now you have to take what? 5 parts out of these 8 parts. 1, 2, 3, 4, 5. So here it is. It is minus 5 by 8. So now you understand how to put these. Let me take some complicated cases. See. Let me dot 2 or 3 number lines so that I don't have to take time for that in the end. Now suppose I have to do, I have to put say minus or let me take some improper fractions. I have to take say 4 by or let me take, suppose I need to put 7 by 3. Here I need to put 5 by or 15 by say 7. Something like this I want to do. Now 7 by 3 is an improper fraction. What will it become? It will become 2 1 by 3. Look at the denominator, 3. Each unit has to be divided into 3 equal parts. So I start with, okay, 0, 1, 2, 3, this becomes 1, 1, 2, 3, this becomes 2. Because I need this number naturally is more than 2 but less than 3. So naturally I'll have to go up to 3. See once again how I did it. Denominator is 3. So I have divided it into 3 parts. 1, 2, 3, 1, 2, 3, 1, 2, 3. And 2, 1 by 3, this is what is 2, 1 by 3. 15 by 7, or let me take something simpler. Say suppose I take 10 by 7. 10 by 7 becomes 1, 3 by 7. Denominator has 7. So every unit has to be divided into 7 parts. So 7 parts make 1 unit. 1 is the same thing. So 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 like this. 1 unit I have to take complete, no problem. And then from the next unit I have to take only 3 parts. So this is it. This is my required number. What will it be? 10 by 7, or you can call it 1, 3 by 7. Now the same applies when you go on the negative side. Suppose you want to do say minus 5 by 3. Minus 5 by 3 is minus 1, 2 by 3. Everything has to be divided into 2 parts. So, sorry, 3 parts. So 0. And how many parts you need? It is going to be on the left side of minus 1 and the right side of minus 2, or I could say between minus 1 and minus 2. 1, 2, 3. 1, 2, 3. So somewhere here, minus 1, okay, I come to minus 1. Then I need 2/3 more, 1, 2. So here it is. This is the number I get. Now let us take one more, say minus 11 by 4. Minus 11 by 4 is what? Minus 2, 3 by 4. Denominator is 4 and this is minus 2, 3 by 4. Minus 2, 3 by 4 will lie between what? Will lie between minus 2 and minus 3. So we have to move from the 0, we have to move to the left side. And each unit we are taking how many parts? Denominator is 4, we are taking 4 parts. 1, 2, 3, 4, minus 1, 3, 4, minus 2. And 1, 2, 3, 4, this is minus 3. We have to take minus 2. So, okay, we are at minus 2. Then we have to go 3 by 4 more on the left side. 1 by 4, 2 by 4, 3 by 4. Here we come. So, minus 2, 3 by 4. Now, with this, I hope you have learnt how to locate numbers on the number line very easily. Thank you.